How have shoreline change rates varied along the Bournemouth seafront since 2005? Why is it important to measure shoreline change rates? Measuring shoreline change rates is crucial, as by analysing these shoreline trends, it can show which areas are prone to coastal flooding and erosion, which are now increasing risks due to climate change causing sea levels to rise. This data can help coastal management strategies, as looking at the changes over time can help predict future shoreline trends and give us an indication of what type of coastal measures may need to be implemented, for example, hard or soft engineering. Implementing these measures early can help protect residents, ecosystems, and the environment. Data and methods used. I used Google Earth Pro to plot 10 points along a 1 kilometre transect across Bournemouth Beach. Each point had a 100-metre interval. This can be seen in Figure 1. I then used Google Earth Pro to collect past aerial images. These images ranged from 2005 to 2022. I used 10 of these images to help me with calculating the shoreline change rate. Figure 2 shows an aerial image from 2005. The pink line is the high tide line, which I used as my baseline when calculating shoreline change rates. Discussion and analysis. Figure 3 shows that the high tide line varies throughout the years. To complete my graph, I measured the distance between the high tide line in 2005, which I used as my baseline, to each individual year. Overall, the trend of the high tide line suggests that accretion is taking place across the beach. The graph indicates that from 2017 to 2022, the beach mainly accretes sediment. This could be due to the new beach nourishment plan that started in 2015 and is set up to continue to 2032. In 2016, 355,000 metres cubed of dredged material was distributed on the beach between Bournemouth Pier and Solent Beach. As well as this, in 2021, a further 350,000 metres cubed of sand and beach material was added to the coastline. This means there's more sediment on the beach, reducing the impacts of coastal erosion. Figure 3 indicates that further west of the beach is suffering a much higher rate of erosion as the high tide line distance from the baseline has decreased. This could be a result of the groins on Bournemouth Beach as they stop sediment from reaching the lower parts of the beach by reducing longshore drift and trapping sediment. This disrupts the natural sediment transport process. Research in Bermudas, Algeria, highlighted that groins have an impact on the beach by controlling sediment and cause erosion along the beach, indicating their role in altering sediment distribution patterns. To calculate the shoreline change rates, I used the endpoint rate equation. The change rates in 2022 are significantly higher than those in 2007 across all points on the transect. This can be seen in Figure 4. This shows the beach accretion. Both lines once again show a decreasing trend heading west along the beach from points 1 to 10. This could be due to the beach groins disrupting sediment transport. The 2007 rates show a clear decreasing trend along the transect. However, in the 2022 rates, they are consistently low, indicating much less change in recent years and showing an increase in beach stability. This increase in beach stability could be due to renourishment. An example of where beach nourishment has been effective is on the Mediterranean coast of Israel. Research showed a positive impact on coastal erosion through the mitigation of beach nourishment projects. Limitations. One limitation of my project was Google Earth Pro did not have accessible aerial images for every year. Originally, I wanted to do 10 points with 10 intervals increasing every 2 years from 2005 to 2023. Further, some of the aerial images were slightly unclear. This made it difficult for me to see where the high tide line was.